Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, Dr. Elena Hyde, and I'm joined tonight by Quentin Wayrich. We are broadcasting live from the Allan Carswell Observatory located in York University in Toronto, Ontario, Canada. As a reminder, this is part of our special broadcast series jointly with Astronomy.fm, but not directly on their channel. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at about 2 a.m. UT, if that's more your speed. The York Universe production works in concert with our online public viewing. So if you're watching this live on YouTube now, boy, are you in the right spot. Our observatory team is currently running the show for online public viewing, which runs at the exact same time, 9 to 10 p.m. local Toronto time. If you ever get lost and need to navigate back or just want to see some more cool astronomy, you can go to our website at yorku.ca/science/observatory, follow the links to OPV, or click on any YouTube link on there to get back to this channel. And of course, there's lots of other things like tours and stuff we might talk about later. Our broadcast, as a reminder, is still powered by and with a partnership in astronomy.fm, the voice of astronomy. For any questions or comments you have of past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can always find us on Twitter as well with @YorkUniverse or @YorkObservatory, on Instagram @YorkUobservatory, and Facebook @Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation, you can see our website at that same link I gave you before, yorku.ca/science/observatory, and just scroll on down to donations, where we're of course happy to see anything you've got to offer. We are right now monitoring the chat room for questions, and our crew is looking to make some fun comments for you. The current weather in Toronto has been very strange. It's sort of cloudy and then little peaks of sun come out. Right now, it is a bit too cloudy and unpredictable to open up the telescopes. So we are, in fact, showing you some lovely archival footage of those nights when it was clear. If you do happen to get a clear spot anywhere in the general Toronto or Ontario area, there are some very nice planets out tonight, in particular Saturn. If you have a gap towards the east, Saturn has been quite lovely the last few nights. It's at a magnitude of 0.5, so you can see it with your naked eye. Don't even need binoculars or anything. If you do have binoculars, you might be able to make out, of course, little bunny ears. But we've got a lovely Saturn in the east, and of course, Jupiter rising later on tonight as we go past midnight. All kinds of great planet viewing happening in the skies at the moment. Speaking of skies, how are the skies where you are, Quentin?
I am actually on campus at York University right now.
So you see the problem.
Exactly the same, yeah. I'm hoping to maybe get a peek at Saturn later tonight. I'll have to give it a look after the program ends.
Yeah, Saturn is going to be very excellent until probably around 4 o'clock in the morning. So it is wonderful all night tonight. And of course, Venus rising just before the sunrise, just in case anyone watching this show is an early riser. We've got Saturn and then Jupiter, and of course we have Uranus next to Jupiter as it rises after midnight. And then we've got Venus rising just before the sun. So there's a lot of great chances for watching planets, but Saturn is the one that's really going to be up all night. So very, very fun stuff. And
I've
I believe,
always,
oh yeah, go ahead.
I've always loved Saturn. It was always my favorite planet.
Well, it's got the bunny ears, right? Or the sideways ears, I guess. floppy bunny ears, and it's one that you can see with binoculars, and yeah, it's a great planet.
Absolutely. So I was wondering, did you want to talk about some history, Professor Hyde? Are you ready?
Oh, I was thinking we'd start with your Enterprise interesting history item first. I think we've got some this week in the space and astronomy history to round off. But let's go ahead and do the Enterprise one first, and then I have a related one that we'll do after.
I see that. Okay, fantastic. All right. Yeah. So let's talk about the Enterprise. So
Absolutely.
on September 17th, 1976, construction was completed on the Space Shuttle Enterprise, which was the first orbiter in the Space Shuttle program. So Enterprise was intended as a test vehicle for studying the aerodynamics of how the space shuttles would operate in the atmosphere. And as a result, it had no engines or heat shield. It couldn't fly under its own power. Instead, it had to be launched from a modified Boeing 747. Enterprise had its first test flight in which it remained uncrewed and mated to the shuttle carrier aircraft on February 18th, 1977. Crewed test flights began on June 18th the same year, and the first free flight in which the space shuttle was released from its carrier aircraft and allowed to glide to a landing on the runway took place on August 12th. So the original intent for Enterprise was to have it refitted with all the equipment required for powered flight, allowing it to launch into space like the later space shuttles. However, the design for the shuttles changed during the construction of Columbia, making it cheaper to just refit a structural test article to construct Challenger instead of modifying Enterprise. And after the Challenger disaster, there were preliminary plans to refit Enterprise to replace it, but NASA ultimately decided to build a new shuttle, Endeavour, out of structural spares. So this means that Enterprise was never given the capability to go to space. Nonetheless, it remains a vital piece within the history of the space program, which would not have been possible without the atmospheric tests it performed. Enterprise was displayed at the Smithsonian Institution's Air and Space Museum until it was replaced by Discovery in 2011, when the space shuttle fleet was retired. Today, Enterprise sits in the Intrepid Sea, Air, and Space Museum in New York City, having been added to the National Register of Historic Places in 2013. When I was doing the research on Enterprise, I learned a little bit of a fun fact. Apparently, originally, they had intended to name the first space shuttle Constitution, in honor of the United States Constitution. But essentially, a petition was put out by a bunch of fans of Star Trek, more or less, that were suggesting that they rename it Enterprise after the famous ship from the TV series, and they inevitably decided to do that. I really like that. I think that's kind of sweet.
Yes, it's got a much better ring to it than whatever that was, the Bodie McBoatface or something that somebody.
I think that there's a little bit of, to my mind at least, it almost feels symbolic, because naming the space shuttle Constitution really frames it as like an American accomplishment, right? Naming it Enterprise in the context of Star Trek, which kind of envisions this bold space age future for humanity as a whole, kind of puts it into the context of, the space program is a common human endeavor. It's not just an American endeavor or a Soviet endeavor or a Chinese endeavor. This is something that we are all striving toward. And even if, I don't know if the policies that the government passed with regards to like NASA, the programs that NASA ran, always necessarily reflected this, it does still kind of, I don't know, to my mind, it kind of reflects a more optimistic future for the human race. I appreciate that.
Oh yeah, well, and it's worth noting as well, is especially after the Challenger disaster, it was very, very, sort of shocking and confronting to people, and to have something, sort of a very hopeful campaign, as you say, based on an idealized future where the Earth has a world government. It's science and science fiction colliding in a really nice way. Of course, it's got a lot of funny history to it. The original series Star Trek being very, very, sort of popular after it went off of the air with the original Enterprise, having, huge ramifications, not just in the US, but kind of all over the world, and what we thought about space travel. And of course, they had a lot of firsts for diversity and other things. And they actually incorporated the some, I believe, or if not all, of the original cast members of the TV series into the event. So it's kind of been one of the biggest science and sci-fi crossovers. Of course, all of these people who played actors going into space, getting in front of a spaceship that would never go into space is kind of next level. But overall, a very sort of, as you say, I think it's on the heartwarming end of you know, science and science fiction crossovers. And it did, of course, get a lot of press because of everybody involved in it. And it kind of also helped, I think, bring back a lot of the optimism that was kind of took a heavy blow after, you know, after the disaster that had happened.
Certainly. So you said that your point was related to mine.
I did. So I saw you you chose the Enterprise, and I was like, oh, the Enterprise. This is a great topic. But we won't talk about the fictional ship too much. We'll keep it to the astronomy. As you say, it was moved to the Sea, Air, and Space Museum in New York City. Keeping these space shuttles around and this entire launching system that we used to have in North America, it's worth remembering just how revolutionary this system was. And when it was when the last shuttle was decommissioned, it was kind of a great loss, because we lost the ability to sort of have relaunchable components for many years, until very recently. We've seen some reusable components from things like SpaceX. So for my next item, I decided to kind of go the other direction. So as you say, in 1976, this Enterprise space shuttle was completed. But it was all the way in 2012, which both seems very recent and also very far away. In September 21st of 2012, the Space Shuttle Endeavour was decommissioned. And Endeavour was that new shuttle that NASA built out of structural spares, as you mentioned before. So you know, Enterprise didn't get to go, but Endeavour did. And it was September 21st, 2012, so another September day, just, you know, many years later, the Space Shuttle Endeavour, as a decommissioned space shuttle, landed in LAX. So it was actually delivered in California, in the United States, and it was delivered to the Los Angeles Airport, or LAX, and it actually had kind of a very long decommissioning. So the Space Shuttle Endeavour had you know, a pretty good set of missions. It was very successful, and when we were finally ready to decommission it, they ended up doing a whole series of low-level flyovers. So they flew over NASA, they went over a whole bunch of different civic landmarks. I'm not even sure I know all the landmarks they actually went over. And then eventually they kind of, I guess, went across the country, flying over all this different stuff, and they landed in California in the US as their official decommissioning. So this was after, I believe, more than 20 different places actually submitted proposals to NASA to actually display the Endeavour. So they said, okay, well, it's going to go to the California Science Center, and along their way, they went past all kinds of things. And apparently it was actually a little bit of a controversial journey, because once they got to the Los Angeles airport, they had to get through Los Angeles, California, which apparently is a very crowded place. So if you don't know it, it's taking the streets in Los Angeles is not something that's recommended, I believe, anywhere in North America. But they planned a route for it, and they sort of choreographed its exact route through the streets of Los Angeles. And they actually had to cut down trees. They had to remove traffic signals and lights. They actually removed about 400 street trees, some of which were fairly old, which created a little bit of a controversy. The trees were replaced but they had to turn on and off power poles. And of course, the whole way they had news crews lining the streets, and it was basically a parade, but like a very, very detailed parade where things had to be dismantled along the way. They had a bridge weight restriction they had to get around. So they actually had to put it on a dolly towing, and sort of it obviously took quite a while for it to actually get to the Science Center, but it did. And the exhibit was opened in October of 2012. So the Space Shuttle Endeavour Display Pavilion, I believe is what it's called. So it was mounted up there, and there's still pictures you can see online of it trying to move through various neighborhoods of California. And I believe it was sort of kept there as a permanent display, and it joined a very important Canadian endeavor, which is Canadarm. So Endeavour's Canadarm, which was Canadarm1, was originally called the Shuttle Remote Manipulator System. So we've talked about Canadarm before on this show as a really revolutionary space tool that is still in use, actually. Canadarm has been retrofitted several times, and there's a current version up on the International Space Station. So, and people are looking, how do we make the next Canadarm for, of course, the Lunar Gateway and all that stuff. So Canadarm was also on the Enterprise. Just FYI, little fun fact. And it's Canadarm2 that is on the International Space Station, the ISS. But Endeavour had its own Canadarm, and they removed it so that the Canadarm1 could go up to the Canadian Space Agency in the center in Quebec. So I believe it's the John H. Chapman Space Center up in Quebec. So it's mostly in California, but the Canadarm has come back to Canada. There's a few tanks that have been removed since then, but I believe it is still to sea. The missions that it ran, it has several missions. It had STS 49, 47, 54. We had all kinds of great missions coming through there. And the Endeavour, as a spacecraft, it flew its final mission up to the International Space Station. So this was a shuttle that was, in operation, as I say, fairly recently, but 2011 does seem kind of far away now. The STS-134 was intended to launch in 2010, but it got rescheduled for 2011. And the launch eventually happened in June, and that was its final mission. And it of course went up to the ISS, and it was actually photographed as docked. And I believe this was only the second time a shuttle actually got to get photographed docked to the ISS. The last astronaut off of the Endeavour was Mark Kelly, and the whole mission was I should say all of its missions and its whole space lifetime was a pretty good success. So, I mean, obviously following Challenger, as you said before, it was a lot of safety was a high priority for this shuttle, but it overall did succeed. And its successor, the sort of the next generation with SpaceX, Dragon capsules and Dragon 2, they actually named one of the Dragon 2 capsules Endeavour. I believe that was during the Demo 2 mission. So Endeavour making its final landing in California in 2012, plus 3 days ago. And I think together with Enterprise and it sort of marked the end of an era.
Yeah, I remember when I was a kid, when I heard that the space shuttle program had been retired, I remember feeling really sad. I didn't expect that it was ever going to end, which was, I guess, kind of the naivety of childhood, right? Because obviously no program can run forever, even one as iconic as the space shuttle. And it's probably for the best that it doesn't, because we do make improvements on old technologies, and there's certainly a lot of room for development, but it's still it's a piece of history that I got to kind of see the end of within my own lifetime. It's kind of interesting to think about.
Absolutely. And the whole evolution of different space transportation systems, or the official name STS, Space Transportation System, for the shuttle program, it's really, really interesting how it has evolved. But you're right that when they stopped it, the thing is, there wasn't anything immediately to take its place. So we did actually have kind of a gap where all of a sudden there was nothing in North America that we could use for a while. And that has changed. But it was, I think, it was a bit of a loss to see it go.
Certainly.
All right, so I believe we'll move a little bit away from shuttles and space shuttles. Our next event is going to get us farther than any human has gone before, but not farther than any spacecraft has gone.
Yeah, it's interesting that this comes up tonight when we were talking about how we could how we can see Saturn beautifully in the sky tonight. September 17th. 1789 was the day that William Herschel discovered Mimas, which is one of the moons of Saturn. So Mimas is actually the smallest object in the solar system that is still massive enough to be spherical in shape. And based on its density, we can determine that it mostly consists of water ice with very little rock. It's perhaps best known as the Death Star moon because it has this really large, prominent crater, which is named Herschel crater, which is about the third the diameter of Mimas itself. And from a certain angle, it looks like the laser system for the Death Star. Mimas was actually the seventh moon of Saturn to be discovered after Titan, Iapetus, Rhea, Tethys, Dione, and Enceladus. And these are the 7 round moons of Saturn. All the others that were discovered later are too small for gravity to give them a spherical shape. So Herschel was able to resolve Mimas using the 40-foot telescope at the Observatory House in Slough, England, which was the largest telescope in the world at the time. But despite its name, the telescope was actually 1.2 meters wide, not 40 feet wide, as the name implies. It was a little bit bigger than the on-site telescope that we have at the Allan Carswell Observatory. 40 feet was the telescope's focal length. It wasn't the diameter of its aperture. So Herschel had actually discovered Enceladus using the same telescope not even a month prior, on August 28th. Mimas was observed in greater detail by various space probes in the late 70s and early 80s, allowing for the discovery of Herschel crater. Pioneer 11 performed a flyby of Saturn in 1979 and came within 105,000 kilometers of Mimas. And then Voyager 1 and 2 performed flybys of Mimas in 1980 and 1981. So the Cassini probe, which entered Saturn's orbit in 2004, has also captured numerous images of Mimas, including on a close flyby in 2010 when it got within 9,500 kilometers of the moon. So fun fact, the Cassini orbiter is named after the astronomer Giovanni Domenico Cassini, who discovered Iapetus, Rhea, Tethys, and Dione, as well as the ring divisions of Saturn. The largest of these ring divisions, or gaps, in Saturn's ring system is actually named after Cassini, and it owes its existence to Mimas. Any particles on the inner edge of the Cassini division would orbit Saturn twice for every one orbit Mimas makes. So this means that they periodically line up with Mimas at the same location in their orbit again and again. And every time they pass near it, they receive a little tug thanks to its gravitational pull. So because this gravitational influence happens at the same location within the particle's orbit every time, the tugs always point in the same direction. So they don't cancel each other out. They actually tend to slowly add up, and they force all the debris out of the orbit, and they clear a gap. So this special effect caused by orbits lining up with each other is called an orbital resonance, and it's not the only one that Mimas exhibits. Particles in the gap between Saturn's B and C rings would orbit 3 times for every orbit of Mimas. Mimas also performs 2 orbits for every 1 orbit of Tethys, and for every 3 orbits of the smaller moon Pandora.
Wonderful. And of course, all of these moons are really good fun to watch. Let's see here. Let me just make sure I still have my co-host. Let's see.
Yep,
There we
I'm
go.
still here.
All right.
Don't worry about me. I'm still here. I'm just thinking about orbital resonances. They're really interesting. I really love learning about them.
Yeah, and just a little extra tip for anyone who is interested, if you are loving watching the moons of Saturn, if you do have a small telescope, Mimas is probably not one that you will be able to easily see, but there is a lovely tool that you can use to watch Saturn's moons go around. In particular, the Sky and Telescope Saturn Moon Tool, which we have actually linked on our website because it's really, really handy. It's under observers, but you can actually watch the moons of Saturn go around Saturn if you are willing to spend a couple hours doing so. So Enceladus, Dione, Titan, Tethys, and Rhea are all actually in the calculator. And if you wonder, well, why didn't they include something like Mimas? Well, Mimas is actually closer, smaller, and a little harder to see. So it's pretty impressive that this was discovered all the way back in 1789. So Mimas being discovered this long ago, it's like, well, we actually would have trouble watching it with just a small telescope or binoculars. Obviously, I do have to say our 1 meter telescope, we could do it, but smaller telescopes would have some trouble. But if you do want to watch some moons go around, if you get a good view of Saturn through a reasonable sized telescope, maybe a 20-inch or so, you can actually spend maybe 3 or 4 hours. You'll actually see the moons move with respect to Saturn. And you can watch, if you watch them long enough, so several hours for the close-in moons, and obviously more on the order of I believe days or weeks for to watch Titan go around a full orbit. But it's one of the fun things that you can see for yourself. It's like you don't have to take our word for it. If you want to see these moons go around Saturn, if you've got a telescope, you actually can. And that's one of the things that makes, I think, Saturn such a wonderful target for amateur astronomers as well. All right.
Yeah, well, we talked about the Voyager probes when we were talking about Saturn's moons. Did you want to talk about the next item?
Yeah, speaking of Voyager, so if we are going to look at Saturn, it's only natural to talk a little bit about some of the good views and good work done by the Voyager probes. In particular, my next item is going to be from actually 2013. So I guess I'm sort of stuck in the 2010s for my items. But on September 12th, 2013, Voyager 1 was finally officially confirmed by NASA to have entered interstellar space. So it had been confirmed as entered interstellar space. And it took us quite a while to actually figure out that it was in interstellar space. So in August of 2012, they had observed that it might be in interstellar space. And it wasn't until September 12th of 2013 that they were actually able at NASA to confirm that it was truly interstellar space that Voyager had gone into. So the generally accepted date of arrival in interstellar space is now thought to be August 25th, 2012, which is about 10 days before the 35th anniversary of its launch. So it took 35 years for it to get out into interstellar space. The date, of course, means that this is when they think that it first started getting a detectable signal of what's called a true change in the density of energetic particles. So this is a real, what's called a durable change, a measurable change, a believable change in the density of energetic particles at the Voyager location. And it's worth mentioning that, of course, the distances here are absolutely ridiculous. So we talk about Saturn, but we don't often talk about, just how far away things are in space. And that's because it quickly becomes nonsensical to look at it in terms of Earth distances. So things we talk about, drive from Toronto to Vancouver or something. Okay, if you could drive to Toronto and Vancouver and back, round trip, if you could do that 40 times, you'd be about the distance to the moon. But um, everything else is so much farther away. It quickly becomes apparent that the solar system is largely empty space, and Saturn itself is fairly distant from Earth. It takes quite a while for spacecraft to get there. It takes quite a while for any kind of signals to get from here to Saturn. And Voyager was part of this mission early on to explore the solar system, to actually get out into the solar system. And Voyager 1 was launched in 1977 as part of the Voyager program to get out and see what the solar system looked like, because we did not have, actually we still don't have very good pictures of things like Uranus and Neptune, but getting out there and seeing how far we could go. So the Voyager 1 made flybys of Jupiter, which is the 5th planet from the sun, the largest. It has, its mass is more than 2.5 times all the other planets combined, and that includes Saturn. So Saturn is around the same size as Jupiter, but it's only about 95 times more massive than Earth. So it's been said, of course, that it could float in water if it wanted to. Low density planet. So the mission to fly by also included Saturn's largest moon, Titan, which is, of course, a very interesting study in and of itself. Titan is the largest moon of Saturn and the second largest in the solar system, and larger than, I think it's still larger than any dwarf planets, but I'll need to check my dwarf planet list for that.
It's actually larger than Mercury as well. It's a very, very large moon.
It's a very large moon, and of course, it's the only it's the only moon known to have a dense atmosphere, and it's the only place in our solar system other than Earth that we know that there are stable bodies of liquid. I won't say it being water, but it's a liquid, surface liquid on Titan. And this is, just one of the moons of Saturn. And we've talked about Titan before on this show. Of course, the Cassini-Huygens mission, going and finding lakes of liquid hydrocarbon, cryovolcanoes, lots of nitrogen, and methane and ethane, some sort of organonitrogen haze, wind and rain, but not for water. It's dunes, rivers, lakes, and seas, but using methane and ethane. So really different chemistry than anything we know on Earth, but so Earth-like in so many ways. It has a methane cycle that's very similar, or we think it's similar to Earth's water cycle. It's absolutely awesome. And of course, this is just one of the many, many moons of Saturn, being out past what's called the ice line. Lots of water and ice can exist much more easily. And, Voyager 1 doing this initial flyby kind of showed that, it was worth following up. And I think that it definitely helped to pave the way for the Cassini-Huygens mission later on. The Voyager 1 probe was followed by Voyager 2. So the extended mission took it as far out as it could go. So it went past Saturn, and went past Titan. And they had a choice of doing either a Pluto or a Titan flyby, actually, when they originally did this. And they chose Titan over Pluto. So it was many, many years before we got the lovely heart picture of Pluto, because it didn't get imaged until quite a bit later from New Horizons. So that was I think in 2015 we finally got the first good image back. But Voyager 1 sort of kicked it all off, and after it got done flying past Titan, it kept going. It kept going deep into the icy outer area of the solar system. It didn't really fly by any other objects because there's just so incredibly much space out there. You just wouldn't run into anything. But it did eventually cross the heliopause, which is where the sun's influence, our sun, has it. It's basically where our sun kind of loses its influence over the interstellar medium. So the solar wind is kind of brought to a stop, if you will, by the interstellar medium, the whatever is out there outside of our solar system, dust particles mostly, but not very many of them. And that's where your solar wind isn't strong enough anymore to push back the winds from other stars. So your interstellar medium is different from your solar system medium. So that empty space that you're flying through isn't really empty, basically. And because of the differences in how much it was very much not just that little bit of particles and high energy things that were out there, they're able to see the difference, but it took a while to verify. And once they were sure, they said, yes, this is actually the heliopause and we are in interstellar space. They actually tested a maneuver correction, a trajectory correction, in 2017. So this is very recent. And this was the first time they tried to fire the thrusters on Voyager 1 since 1980. And they actually were able to actually do a trajectory correction, and they expect to keep getting data back from Voyager 1 until about 2025, when that's about when they think that its generators, its radioisotropic thermoelectric generators, will no longer be able to supply power to operate its scientific instruments, because at that distance from the sun, solar power would not do much for you. So anyways, Voyager 1, this day in history, confirmed to enter interstellar space, flying out into the icy darkness, never to return, unless of course you watched that Star Trek movie. But that's the science fiction part of that.
Crazy to think that we have built something on Earth that is now in interstellar space. That's just incredible to think about.
Yeah, and of course people have wondered, is it going to run into anything? And the answer is just no, not as far as we can tell. There's not even really any stars pointed that way. So I think it's oh gosh, several hundred, as I recall off the top, this is just from memory, I believe it was several hundred light years before it has a chance of encountering anything. So it's just going into the icy outer space, and we'll see if we can still talk to it in 2025.
All right. So speaking of really groundbreaking missions, I did want to talk about this other event here. September 21st, 2003. So earlier I mentioned some of the history of the exploration of Saturn and its moons. So in a similar vein, September 21st actually marks the 20th anniversary of the end of the Galileo mission to study Jupiter. So the Galileo probe was launched on October 18th, 1989. It wasn't the first NASA space probe to visit Jupiter. Pioneer 10 and 11 had performed flybys of the planet in 1973 and 74, and Voyager 1 and 2 had also flown by Jupiter in 1979, but none of these probes remained in orbit around the planet. They continued past it to the outer solar system and beyond. Galileo, on the other hand, was intended to remain in Jovian orbit until the end of its mission, collecting as much data about the largest planet in the solar system as possible. So initial plans for Galileo's launch had involved mounting it atop a Centaur G prime upper stage rocket engine, which could get it to Jupiter in 2 years if launched within the planned window in May of 1986. However, the Challenger disaster in January of that year prevented the initial launch date from being met, as all the space shuttles were grounded during the investigation into the causes of the disaster. Furthermore, the increased scrutiny NASA was exposed to in the wake of the disaster led to the plans to use a Centaur rocket engine being canceled, as this was deemed too risky. So the team would have to find a way to get Galileo to Jupiter using only a 2-stage inertial upper stage rocket engine, or they'd have to scrap the project. So eventually, a clever means of pulling this off was found, a series of gravitational slingshot maneuvers that could boost Galileo's speed. The planned trajectory would require Galileo to fly past Venus and then past Earth twice in order to get enough speed to reach Jupiter. The encounter with Venus happened on February 10th, 1990, and on December 9th, it performed its first flyby of the Earth. This was the first time a space probe had ever returned to Earth from interplanetary space. The second flyby happened in December 1992. And fun fact, during the interval between the 2 Earth flybys, Galileo performed an experiment to attempt to identify the so-called Sagan criteria for life, which are potential signs that a planet is inhabited by living things proposed by Carl Sagan. It attempted to perform these on Earth itself from a distance. It's essentially a way of checking if, these things really are verifiable with the planet that we really do know has life on it. And Galileo did indeed find these signatures. It performed the first ever control in the field of astrobiological remote sensing. This was kind of a breakthrough in the study of astrobiology, because we were able to verify that, the things that we expect a planet with life on it to possess, we really can see these signatures, at least with the Earth. So the spacecraft reached Jupiter in 1995, releasing a probe which passed through the planet's rings and entered Jupiter's atmosphere. The orbiter, meanwhile, began a series of highly elliptical but generally stable orbits around Jupiter, which would also allow for close-up flybys of Jupiter's largest moons. It flew past Io, Callisto, Ganymede, and Europa several times and captured images of several small inner moons like Phoebe, Amalthea, Adrastea, and Metis. In November of 2002, the space probe experienced worsening problems with its tape recorder, and NASA decided to decommission it by having it fly into the Jovian atmosphere and burn up. This occurred on September 21st, 2003, but not before Galileo was able to contribute greatly to our understanding of the Jupiter system. It is thanks to Galileo that we know that Jupiter's chemical composition differs significantly from the Sun's, meaning that it has evolved since its formation in the early solar system. Galileo was also able to show that Io has volcanic activity 100 times greater than that on Earth, and also provide evidence for the existence of liquid water oceans beneath Europa's icy crust.
Yeah, very, very enticing. I remember the first time I saw a video for Europa's icy oceans. And it's just captured the imagination of so many astronomers, I think. And we talked about Titan, how it was so interesting because it's so Earth-like, having liquid water and clouds, or not liquid, not water and clouds, I should say, methane and nitrogen, but that's not actually liquid water, which is what we have on Earth. But Europa, it totally has liquid water, and you can see it leaking out of the icy crust. And the fact that we've had so much interest in Europa, I think it really was kicked off by this mission in a large part. And people have been just wondering, how do we get a submarine into that ocean? Because it would just be so interesting to explore. And the Galileo spacecraft did amazing work in very, very extreme conditions, because of course the radiation belts around Jupiter were pretty intense.
I recall hearing that the oceans on Europa are suspected to be like way deeper than any of the oceans on Earth. I don't remember the exact number for like how deep they are, but if anything does live down there, it's evolving under conditions completely unlike anything on Earth.
Well, it's really interesting because of course you don't get a lot of sunlight out at Jupiter, and Europa wouldn't be getting a ton of sunlight from the sun, and it has an icy crust. So whatever it did get would be heavily dissipated by the thick icy crust, but it gets a lot of energy from gravitational heating between the other moons of Jupiter and pulling on it. And so it has all this potential internal heating mechanisms. But yeah, it does have more. I mean, if the density estimates are correct, according to the math that's currently out there, Europa, the moon, has more water than the entire Earth. Like if you bundled all the oceans of Earth into a bundle and pulled all the water out, that would be less water than one Europa. Again, according to estimates, but the potential for having an absolutely massive ocean, much larger than our entire oceans of Earth, is there, but we don't know because we've never been under the surface. We don't have that submarine yet. And of course, looking for plume activity and looking for water sort of leaking out the cracks on the surface will only get you so far. So it's really tantalizing, I have to say.
Certainly.
All right. So I think it's about time, well, a little bit past halfway, but about time I remind everyone that you are, in fact, listening to York Universe. We're broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you have any questions or you want to search for more of our content, you can always go to our website at yorku.ca. Excuse me, yorku.ca/science/observatory. You can follow us on Twitter at York Universe or York U Observatory. We're, of course, Facebook and Instagram as well. And tonight you're listening to Quentin and Elena, and we're discussing, right now we're discussing the icy outer solar system, I guess, and interesting space missions. This is part of the online public viewing, and as a reminder, we're not directly on astronomy.fm tonight, but they are our partners in this broadcast. So that's our little reminder of what we're doing roughly halfway through the show. There's also a couple other little tiny reminders we just want to let everybody know about. And the big one is that weekly tours are back at the Allan I. Carswell Observatory. So that is weekly Wednesday tours. Wednesday nights, we have our observatory in some fashion open. This week, we are having an atrium tour. So if you go to our website, which I know I've been telling you over and over, but yorku.ca/science/observatory, all the tickets are free, but you just go to the Eventbrite link and you click on the free ticket and it says either observatory tour or atrium tour. So this week is the atrium tour. We'll all be on top of the Arboretum parking garage, which is just across from the Petrie building at York University. It's on top of the roof, and we'll have a bunch of small telescopes that we bring out and show you anything that we can see. So this Wednesday's tour is weather dependent. If it's cloudy or raining, we won't be able to bring the telescopes out. If it's an observatory tour, that will say it on your ticket. That's the other kind of Wednesday tour. Those are not weather dependent, so they can happen inside the observatory, even if it's cloudy. All right, so that's our weekly reminders of tours are back, and this Wednesday we definitely have one, just if it's clear. So if you're in Toronto and it's bucketing rain, don't come out, but otherwise you're all invited. Now I think we have time for some news items, and Quentin, you've got a really lovely one with closest black holes to Earth. I loved this article when I saw it come out a little bit ago, so I think I'll let you go ahead and start.
Thank you. Yeah, I'm excited about this too. So using data collected by the Gaia satellite, Spanish astronomers have discovered promising evidence that the Hyades star cluster may contain black holes. So Hyades is an open cluster that makes up the head of the bull in Taurus. It's 153 light years away, one of the closest star clusters to us. So this means that if these results are correct, the Hyades cluster contains the nearest black holes to Earth that we've discovered, at least. Open clusters are young, gravitationally bound collections of stars that typically all form together. The oldest and most massive stars within these clusters are the best candidates for forming black holes at the end of their lives. Gaia data on the movement of stars within Hyades was compared to simulations of how the stars in Hyades ought to behave with or without the presence of black holes. The simulations were found to only match the Gaia results, as well as the measured size and mass of Hyades, if 2 or 3 black holes exist inside the cluster or have only been ejected from it recently. The complicated gravitational interactions between all the astronomical objects within a cluster do indeed frequently result in objects being ejected from the system. But if Hyades used to have black holes that have since been ejected, this must have happened less than 150 million years ago in order to match the observed data. So this is a really short timescale by astronomical standards, which means that if there were black holes that end up getting tossed out, they should still be nearby. More observations need to be taken in order to prove definitively that these black holes do exist, but the study seems to indicate that analysis of the position and trajectory of stars within a cluster may give researchers a new and exciting way to find black holes.
Very, very fun. And of course, the closer the black holes are, the sort of more resolution you can get off of your measurements. So there is something to be said for trying to find one nearby. And it's worth mentioning, as you say, the Hyades cluster just 150 light years only. When we were talking before about Voyager 1 and 2 leaving the solar system, Voyager 1 has gone past the heliopause, but it's not outside of the Oort cloud, which takes us all the way to 1 light year, I believe, as I say, best estimates. This nearby Hyades star cluster is 153 light years. So our very farthest spacecraft escaping the solar system is going through about 3.5 AU per year. That's Voyager 1. And it still hasn't made 1 light year. That's how incredible the distances are when we're talking about these quote unquote nearby things in our galaxy. And of course, if you leave our galaxy, it gets even sillier. It's probably also worth noting that neither Voyager 1 nor 2 is actually pointed in the direction of the Hyades star cluster, unfortunately. So
that is unfortunate.
But even if you were to wait,
we're not going to lose them to a black hole.
None that we can see, anyways.
I wish that somebody had told me how far away all the black holes that we know of are when I was a kid, because I remember when I first learned about black holes, I was terrified of them. I was like, oh no, what if I fall into a black hole and I get all stretched out and I get I can never escape. It's like, none of these objects are anywhere near the Earth,
No.
which I guess is reassuring. It's good to know that of all the things to be worried about, falling into a black hole isn't really on the list.
Yeah, well, that is something that's worth emphasizing, especially if you're discussing spaghettification or how things get stretched out when they get too close to a black hole. And it is true that there are smaller black holes out there, and in particular, we do have things like microlensing and strong and weak lensing that can be caused by gravitational lens effects. So there may be closer black holes that we just don't know about because they are smaller and not currently causing any effects on other stars. Because of course, you can't see the black hole directly; you can only see it operating on something else, and that's something to watch out for a little bit, but still like so incredibly far away. Very, very, very far away, 153 light years. And our very farthest Voyager 1 is still the farthest, I think. Has not even gotten one light year away. And it is crazy, the distances out there.
Right.
So we do have, I think, just enough time for one more.
Yeah, I'm excited for this last one, and then we should be enough to call it a night.
Yeah, I think so as well. So there's one more little news item I just couldn't resist putting in. We only have 5 minutes, but I think we can cover it. So we talked about the black holes, which are really, really interesting stuff. But a little bit closer to Earth and something you can see is the moon. And the moon remains so interesting right now because everybody is talking about water on the moon. And, 10, 15 years ago, you wouldn't have heard anyone talking about water on the moon in any big way because it was just like, no way, that's not going to happen. There was no real scientific mechanism that was proven. There were theories, certainly, but lunar water has become huge after, of course, Chandrayaan-3, their successful landing on the moon by the Indian Space Agency, the ISRO, and finding out that there is water on the moon in these permanently shadowed craters has been game changing. Because of course, if there is water there, maybe we could use it. So it's kind of an interesting question. What kind of water is it? Would it be usable? How much is there really? And so figuring out how much water is on the surface has been an ongoing, I suppose, debate. The South Pole is where Chandrayaan-3 has landed, and that's what's currently being investigated. But how many of the moon's permanently shadowed regions have water? And if there are, several permanently shadowed regions, you get a better chance. But the two papers that I'm going to talk about today are showing that two things. One, a team from Southwest Research Institute actually calculated that the permanently shadowed regions now on the moon tend to be younger, or at most about 3.4 billion years old. So not as old as for example, the entire solar system. So they're younger-ish. So those could contain what's called quote unquote relatively young deposits of water ice. So that means that because the craters are not as old as the solar system, the water ice would have landed later. Water resources are key, but the calculations in the paper actually show that maybe some of these craters don't have as much water as we thought. And as the moon, of course, migrated slowly away from Earth, it actually had a couple important things happen in its history. About 4.1 billion years ago, when the moon was much closer to Earth, it actually experienced a major spin axis reorientation, we think. And that would have changed how the moon actually created these permanently shadowed regions. So those are places where the sun would never shine, basically, inside these craters. So if there was an axial tilt reorientation, that means that your permanently shadowed regions could change. So some of your water could go away. So the argument in this case is because the shadows have changed as the moon reoriented itself, a long, long time ago, 4.1 billion years ago. You had early Earth and early moon, and the moon was much closer, and it was a whole very different situation. But your shadowed craters would have changed over time. And if a lot of our permanently shadowed craters are new, then of course, how would you have a lot of water in them? So it throws a little bit of a wrench to the idea that there might be just tons and tons of water. There certainly won't be anything like the amount of water we see on Europa, for example. So this came out fairly recently, and in the same news blast, just two articles down, there's another a paper that's come out from the University of Hawaii. Planetary scientists have actually found that high energy electrons in Earth's plasma sheet could actually contribute to weathering processes on the moon's surface and actually aid in forming water ice on the moon. So just this week, we have two papers, one showing that the PSRs, or the permanently shadowed craters, might not be as good at holding water, and another one showing that actually maybe, again, maybe, perhaps there is a chance that some water is being formed with high energy electrons in Earth's plasma sheet being sort of blasted off towards the moon's surface and helping to aid formation of water. And these high energy ions for basically space weathering is something that has been looked at before, but I haven't seen a lot of other papers talking about water formation due to this high energy ion bombardment. So we have, even right now, wonderful, wonderful scientific disagreements about how much water is on the moon, and I cannot wait until we get to go there and find out for sure.
All right, I think we're at the end of the night now. Do you want to sign us off, Dr. Hyde?
Absolutely. So on that happy note that we still don't know about the water on the moon, I think I'll call this show to a close and say thank you everyone for joining us for all kinds of fun space stuff tonight. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Quentin Wayrich and myself, Dr. Elena Hyde. And this is our astronomy.fm partner broadcast over on our YouTube channel. You can always connect with us on Twitter at York Universe or York Observatory, Instagram with York U Observatory, and Facebook at Allan Carswell Obs. And as always, if you really want the best updates, please see our website, yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.
Have a good night.